My name is Amos Winter, and I run a group at MIT called Mobility Lab. And what we do is develop mobility technology for developing countries with collaborators who are wheelchair manufacturers and disability groups throughout the developing world. So what I'm going to talk about right now is called the Leveraged Freedom Chair, and it's a wheelchair that we're working on specifically for use in developing countries. The motivation behind this project is that existing technology does not fully meet the needs of wheelchair users in the developing world. If you have a wheelchair or a hand-powered bicycle that's like a bicycle but you power with your hands, a wheelchair is very difficult to ride off-road, and a hand-powered tricycle is too large to use in your home. So what's needed in the developing world is one device that can comfortably let you travel long distances on rough terrain, but is also small enough to use in your home. This is one of our Leveraged Freedom Chair prototypes, and it's one of 8 that we built in August, and 6 of these are being trialed right now in East Africa. And the whole trick behind the device is that in order to achieve various mechanical advantage, to go fast on flat ground or to be able to go through sand or climb hills, all the user does is move his hand up and down these levers. So if you need to get a lot of torque, if you need to go through sand or mud, you just grab high on the lever and you get this long lever length and get enough leverage to propel yourself through that rough terrain. And as you slide your hand down, keeping your hand speed constant, you achieve a higher and higher angular velocity, rotational velocity, which makes the chair go faster. So we've designed this system to optimally convert the power that you have in your upper body through a wide range of terrains. So you can go 5 miles an hour on the street all day long at peak efficiency, or these levers give you the mechanical advantage required, so you can use your peak force to muscle your way out of like sand or really rough situations. Other points on the chair is that every single moving part in the system is made from a locally available bicycle part. So you can literally build this chair in your back shed with a hacksaw, a welder, and a vise. And that means we can make this chair anywhere in the developing world and also repair it absolutely anywhere. And it also lets us make the chair for about the same cost as existing wheelchairs in developing countries, about $200, and that's what wheelchairs and hand-powered tricycles cost. When you're done using the levers, after say you've traveled from your house to school or to your job, all you have to do is take them off, and they store behind the seat. And then you're left with just a conventional wheelchair that you can use just like any wheelchair indoors and be able to use a bathroom without having to crawl on the floor and maneuver around your house.
Can you describe what some of the barriers to decreasing the cost would be and what some of the most expensive parts of the wheelchair are?
Well, the materials, like the raw steel, is probably the most expensive material on the chair. And increasing economies of scale of production is the best way to decrease costs. So there's similar developing country wheelchairs that are made in Vietnam that cost $150 per chair, just because they're able to produce maybe 500 units a month. If this project scales up and we're producing thousands a month, maybe we can drive that price down to $100 a chair. But the cheapest wheelchairs available now that are given out for free in developing countries cost about $100 to $150 per chair. So there's really no barriers preventing us from achieving that level of price.
How have you tested this chair, and what are your future plans for moving the project forward?
Yes, we've conducted testing in the United States, performance testing of this chair versus existing products. So this chair is about 20% faster than a normal wheelchair on flat ground, and it will beat literally any product currently available off-road, except very specialized high-end US-made wheelchairs. So there's no device that has the breadth of operational capability that this chair does. Right now, we have 6 of these chairs being trialed in East Africa, 4 in Kenya, 1 in Tanzania, 1 in Uganda, and we will use the feedback from those trials to modify the design and prepare for large-scale production.
And can you just describe briefly the limitations of how far can this wheelchair go? What kind of surfaces, what kind of speeds is it able to achieve?
I think your body would be the limitation in how far this wheelchair can go. It is designed to allow you to travel on common terrains like dirt road, 5% grade hills, tarmac, at your peak metabolic efficiency. So with a heart rate increase of only about 20% from what your resting heart rate could be. So it's like walking. You could do it all day long. It's also designed such that if you get in a rough situation like sand or mud, you can use your peak pushing force, like a bench press, to be able to get yourself out of those situations. So its limits of terrain that it can travel are about anywhere from tarmac up to about deep, soft sand, maybe sand where your wheels are sinking in 2-3 inches into the sand. So you can easily travel on a beach with this. And in hills, it depends on how much trunk control you have. If you can lean farther forward, you can go up steeper hills. But about 1 in 4 slope is probably the max you can go up. And we regularly go up like 1 in 3 slopes, which are 4 times steeper than what a wheelchair ramp could be in the U.S.
Great, thank you very much.
Sure.